morning and welcome to our second panel discussion today on component shortages and avoiding counterfeits. A lot of companies are having issues with component shortages at the moment, and that's driving them into the grey market and running the risk of having counterfeits getting into the system. So we're going to discuss this with this panel. There's a couple of really interesting new technologies coming in here that might help address this problem. To my extreme right, we have Radu Diaconescu from SMIC.
Hi.
Hi there. To his left, we have Craig Lax from Septillion.
Hi.
Okay. And to my right, we have Michael Ford from Aegis, who's also on the IPC traceability committee driving this.
Yep. Hello.
Nice to see you again, Michael. Okay. So, according to the US military, there's reports that are saying that as much as 15% of their inventory is counterfeit, and 70% of that counterfeit can be traced back to China. So if this is happening in US military applications, what's it like in general manufacturing?
You can only wonder, can't you? I mean, a lot of the techniques for combating counterfeit kind of start and end with detection. Mm-hmm. Nobody really wants to come clean about how much they've actually found or imply a risk that they may not have found it. And so it is really, really difficult to get an understanding of that. But the US military, I think, have been extremely brave about putting this forward and saying, look, this has to stop.
Mm-hmm. Mm-hmm. Absolutely. It's been a huge... the problem has only got worse with the success of the industry over the last couple of years. You know, it's driven a lot of people onto the grey market. What do you think, Craig?
Well, we work in other industries as well, and it's common that it's 10% of global trade is counterfeit across every.
You think
every
about 10%
industry.
across the board,
and that's $1 trillion market. So.
I think part of the problem is the fact that we actually have to ask this question, right? So if we don't know the extent into normal electronics manufacturing, I think this is part of the problem, because normally it's hard to eliminate all counterfeit materials, but you have to start somewhere, and that start has to be realizing how much the extent of the problem, and the fact that we are not able to grasp how big the problem is, I think is actually the main issue that we're discussing.
That kind of circles back to Michael's point, which is people don't want to tell you. They don't want to have their dirty washing in public.
That's one aspect of it, but the other aspect of it is the fact that the supply chain in electronics is complicated, complex, and is getting even more complex. Mm-hmm. And it's hard for any company or for any institution right now to have visibility across the spectrum. So to be able to evaluate things across the supply chain. And that's probably one of the main issues that we're having at hand.
Okay. So what are our options?
I don't think there are any more options just to continue the way we are. We need to find, and what we've been talking about together, the three of us, within the bounds of IPC, we need to find a way that eradicates counterfeit completely.
Right.
So using a combination of technologies of tamper-proof labeling, tamper-proof packaging, the use of blockchain to have tamper-proof data, to be able to make a secure tamper-proof handoff of information from original material manufacturers all the way through to those who would consume it. Right. Now, if we can, I mean, the way it reflects into traceability is that we can do that right now on the shop floor by taking data from machines and understanding if there is any issue with a material, we can trace that back to the exact package at which it arrived.
Right.
Now, that's fine, but we then need to be clear on who has the responsibility for that package arriving. And so what we've been doing is to put together the combination of ideas through the use of technologies to create that environment in which people who are using materials can see a package, can see it's not been tampered with, can read a label that cannot be copied, and they will accept that material on trust from their distributor and their supplier.
Okay, the key point to that is, of course, being able to read a label or some other marker that cannot be copied.
Absolutely.
What do you think about that, Craig?
I mean, you're absolutely right. It's when you're talking about traceability of physical assets. So you've got the physical world and the digital world. So you've got serialization solutions where you can, track and trace essentially, but you're always got the physical asset. So you have to look at physical solutions, and whether that's tamper-proof labels or solutions built into the products themselves, or some kind of covert solution.
What is Septillion suggesting to use as markers for this?
Well,
or identifiers, should I say?
It's horses for courses as well. So not one solution won't fit every component, every material, but you will need to use a combination of technologies. But we're looking at a covert tagging technology that can be applied to packaging, labeling, and certain components, materials.
Okay.
So.
Radu, what is SMIC working on? SMIC is a consortium of companies. So what is the consortium's approach to this problem?
So we're essentially building a consortium of companies relevant for the value chain of, on one hand, the electronics industry, and on the other hand, the whole product design and manufacturing. So we plan to go also into additive, CNC, and other types of manufacturing. But we are building this consortium is because we think that the problems that we have at hand are too big for one company to solve, regardless of how big that company is or how much leverage that company has in the industry. It's just from a one company perspective, you cannot push change throughout the supply chain. And that's where the whole, the consortium idea came into place, and also working with IPC, because IPC has, let's say, the oversight over the whole industry and can see and can impose some sort of best practices in a non-biased way.
Right. Once you get the methodology agreed, basically you need to then encapsulate it in a standard, so
exactly.
that everybody's working with the same rule book, basically.
Exactly.
Yeah, it was interesting in the meeting that we had yesterday. It's clear about how much concern and interest there is about the ingress of counterfeit materials and how helpless people seem to feel. So what we wanted to do in the meeting was to bring guys like these two guys together with their examples of technology. I mean, the packaging here, we've got little fibers embedded within paper. You light them up with a UV light and you can see this is like a fingerprint. Right. And there are other technologies as well that will work in different places. But we have the technologies right now. We look at blockchain. I mean, there are several people producing blockchain. We had a little demonstration about how we can track securely the movement of materials, even unpacking them, repacking them, consigning them. The information is there. And I'm getting too old to continue to talk about these kind of problems without actually finding solutions. Right. And I think that IPC, through things like CFX before it, are really in the right place now to start this new age of standards that are going to apply throughout the whole industry, not just of electronics, but well beyond. We have to start somewhere, and as you said, go step by step. Right. So here's the line in the sand. Here's the line that reflects the will of the market that says we cannot continue without a standard and without using the technologies that we have to solve the problem that, if we don't do anything, is going to result absolutely, it's not just likely, it's absolutely certainly in a world-changing event. Yeah. Because we've got counterfeit products in military, in aerospace, driverless cars. It's not acceptable.
Absolutely not.
And so that's why we're driven to do it. It's a
multi-billion-dollar problem.
Exactly.
Taking in the topic of blockchain. Blockchain, obviously, you're talking about using that for the vehicle for transporting this data securely. Is that fail-safe?
Not on its own. No.
Not on its own. Okay.
And you know, there's. I mean, it's cryptographically secure. It's a good digital platform.
Mm-hmm.
A good digital shared data infrastructure.
Right.
But of course, again, you're dealing with physical assets, and that's where we come in. You know.
So Radu, I mean, your group is also looking at blockchain as the method of transporting this data securely.
So I think this question about security has a lot of layers. So a blockchain in itself, by default, is public, right? And that's one of the advantages, because being public, you can authenticate, you can manage, you can log data, and everybody agrees on universal truth, and then you can refer to that and see any potential conflicts. Now, from that, there are a lot of technologies and a lot of algorithms that can provide certain protections in certain aspects. So to your question, yes, it is secure, and we can design, and that's what we're trying to do at SMIC, to design exactly the right pieces. So to define, for example, what data needs to be public and what data can be stored directly on the blockchain. For what data do we need to use zero knowledge proof? So zero knowledge proof is a concept where we can talk about certain pieces of data, and I can make sure that you know a certain secret without you revealing that secret publicly. Right. So those are highly sophisticated algorithms that come into place. So by defining this standard together with IPC, I think this is the place where we need to pay attention, and we need to think of, yes, here we need to, we actually benefit from having the data public, and having the public blockchain, because that actually ensures, if you have a public blockchain, you have a high number of nodes, it ensures a security, right? So the network cannot be attacked.
Right.
Or it cannot be attacked easily or cheap.
Actually, I love the way you described it in the meeting yesterday, because, you know, let's say we had 100 people in the meeting. Everybody takes meeting notes.
Right.
One person decides to change something because they want to influence the result. But you've got 99 other copies that disagree with that. Now, blockchain divides the data up in the same way. And if 99 people think one thing and one person thinks something else, obviously you're going to go with the majority.
Right.
And that's as simple as blockchain is.
Right.
It's simply a matter that you cannot, tamper with the result unless you were to tamper with 51 copies of the truth. And trying to locate those and get into and hack into that is virtually impossible. Because you don't even know where they are.
Yeah, and that's the main difference between a private and a public blockchain. Right? Because in a private blockchain, if we decide to do, and that's coming back to the points I mentioned earlier, where a blockchain initiative has to be industry-wide. It's if you have a private blockchain, that is actually prone to attacks, because you have a certain company with its suppliers. That's a limited number of nodes.
Right.
However, if you rely on a public blockchain, that is
infinite,
used worldwide, and that has nodes everywhere, it's like storing copies of your data virtually around the world, right? So a malicious actor will have a very hard time to break into those networks. Now, other problems arise, yes, like what's public, what's private, how we ensure privacy of data. This is something extremely important for the industry, but it's manageable.
Right. Okay. We're in very short time, so I'm going to skip to my last question here, which is basically, if we are successful in getting end-to-end security and encryption for materials, what is going to be the effect on the industry? Who are going to be the winners and the losers in this? Because there's a lot of people along that supply chain that this is going to touch.
Yeah, it's going to basically, I'll say revolutionize, but it's actually kind of going backwards. The people who are making the materials are going to be able to have one system of labeling defined by the standard using different technologies, okay?
Some fewer labels.
Yeah, they're going to be able to define the exact information about that material, length, width, height, contents, all of that kind of traceability information. That flows securely then to the distributors. Now, the distributor will be able to subdivide that and still create secure packaging so that when that goes to the end consumer, there is that bond of trust between them. Now, that bond of trust goes back up the supply chain so that you've got a vendor of, let's call it chips, very expensive chips perhaps, and maybe their brand image is being affected now by their chips being counterfeit. Because counterfeit can be eliminated, their brand name does not suffer that loss of value.
Right.
Their customers are happy to continue to use more and more of their products. The distributors are now trusted by the suppliers. There's no need now for this increased incoming inspection. There's no need for so much X-raying of components, although still people will want to do it.
Yep.
But they are safe in the knowledge that were any counterfeit to get in there, it would be tracked back to the source and that person prosecuted.
Right.
So unlike today, that prevents them from doing that. They'll go off and counterfeit something else perhaps, but it won't come to me as a manufacturer.
Right.
That's what changed. We re-established that bond of trust, and in doing so, we are all reducing our costs because the end manufacturer gets all of the detail about the material. And so they save money having to re-engineering what is this material, what batch, what supplier, etc. So we're building into the rules the method for people to gain benefit at each stage.
Right, right. So I agree. You said a lot in that statement there, and of course there's a whole industry around at the moment through X-ray for counterfeiting and all that sort of thing, but that essentially they will still X-ray, but it'll become more a quality issue rather than a a verification issue. Craig, what's your view on this?
Well, I mean, one of the reasons why this has not been done is because, you know, who's going to, you need a trusted third party. You know, like a bank is a trusted third party, or an attorney or solicitor. But blockchain doesn't need that trusted third party. The network maintains the state of the data, and that's really what's going to enable this to happen.
Right.
You just don't, you know, you're all managing the same data.
I mean, it's going to be kind of difficult if the originator is Chinese. I mean, you're not going to be able to necessarily prosecute him that easily, but I guess he'll be prosecuted in the sense that people just won't buy from him.
Exactly. That's exactly the way it should go. It's naturally driven. Yeah.
Exactly. Okay. Gentlemen, we're running right out of time, unfortunately. I think I'm going to wrap it up there, but I think we want to continue this debate, surely, in articles and discussions in the future, and I really want to thank you all for joining us today. So Radu from SMIC at the end there, Craig Lax from Septillion, and of course Michael Ford from IPC and Aegis.
Thank you very much.
Thank you very much for joining us. And thank you for watching.